I'm your host, Andrew Berend. Today's forecast calls for snow, and I'm wearing a swimsuit.
Oh hey, it's Charlie Eikenberg.
Charlie has biceps with similar circumference to that of a man's head. His shirts never wrinkle. If he were to mail a letter without proper postage, it would still get there. His blood smells like the finest of colognes. He bowls overhanded, and his business card simply says, "I'll call you." Charlie's physical stature stacks up comparably to that of Cam Newton.
What's up, guys? It's Charlie, and yeah. What's up? It's Charlie again.
Hey, what's up? It's Charlie again. And, I love Isaac Newton's first law of motion.
As Charlie snaps the ball perfectly to himself, the ball rests at static equilibrium on top of his foot. As no forces are being applied to the ball in the nth dimension, the force of the weight of the ball and normal force acting on the ball from Charlie's foot are equal and opposite. The ball has a net force of 0 with no velocity or acceleration. Charlie then winds up and, releasing a booming kick, launches the ball throughout the air with a similar force as Sebastian Janikowski.
His career long, by the way, in a real game, on a real kick.
Hi, Eddie. Say hi. Hey, what's up? It's Charlie. I'm gonna throw this ball at constant velocity in the X direction because I'm a cannon. Science, bro.
As Charlie reads the defense and calls a string of audibles in a more impressive fashion than Peyton Manning,
So gun, dice right, yo-yo, scat right, Y option on hard.
he takes a beautifully executed three-step drop. As he progresses through his flawless throwing motion, he drops what many call a bomb downfield. As the ball sails through the sky, roughly 85 yards, the ball is at dynamic equilibrium in the X direction. Once the ball leaves Charlie's hand, it becomes a projectile with only gravity acting upon it. Thus, there are no forces acting upon the ball in the X direction. It is traveling at constant velocity, has no acceleration, and Charlie is still really muscular. Newton's first law, sometimes referred to as the law of inertia, describes an object at equilibrium. We have demonstrated the two types of equilibrium, static and dynamic, and subsequently defined that an object at rest will stay at rest until an outside force acts upon it, while an object in motion stays in motion at a constant rate until an outside force acts upon it.
So this is what you want me to push? This is amateur hour. Bro, fine. I'll do it.
As Charlie first pushes the cart, he exerts a minimal amount of force on the object as he believes I am underestimating his muscular abilities. As he exerts this minimal force, the cart does not travel a great distance in the X direction. Charlie then pushes with a much greater force and the cart accelerates much faster and moves a much greater distance, showing off a force similar to a pack of buffalo roaming the plains of the Old Northwest. As Charlie shows off his superior receiving ability, he first drops the ball, exerting a small amount of force in the Y dimension as the ball slowly drops to the ground. Later, after once again demonstrating his receiving prowess, Charlie releases a Rob Gronkowski-like spike, exerting a much greater force in the Y dimension, which results in greater acceleration and higher velocity.
science.
I am at a comfortable 98 degrees. As Charlie first throws the ball to the left in the X direction, it travels in the direction of the applied force until it is caught by Charlie on the other end of the pass. Then, Charlie once again throws the ball, but exerts his force to the right in the X direction, causing the ball to sail into his hands again.
Bro, you want me to dunk on this 12-foot basket right now? Bro, okay. Bro, punt, pass, kick, I am punt.
As Charlie takes a Usain Bolt-like running start towards the basket, he builds up momentum in order to make his jump. As he exerts a force downward against the ground in the negative Y direction, the normal force increases greatly as he accelerates off the ground, showing off his 63-inch vertical leap similar to that of Vince Carter in the 2000 Olympics. Later, as Charlie exerts a small amount of force on the ball in the negative Y direction, the ball falls towards the ground before Charlie unleashes a booming punt. After eating a bowl of nails with no milk,
How tough am I? I had a bowl of nails for breakfast this morning.
Yes, so?
Without any milk.
Right this way. Sorry to keep you waiting.
Charlie goes outside and pushes his car for a few seconds with a constant force. Then, after pushing the car back to the starting point, Charlie pushes the car with the same force for a longer amount of time, thus the car moves a greater distance in the X dimension. As Charlie is ripping out sets on the dumbbell floor press, he only exerts his force for a couple of seconds, thus his arms are not all the way extended. Then, he exerts the force for a longer amount of time, and his arms are all the way extended. As Charlie exerts the force for the longer amount of time, more distance is covered in the Y dimension.
Bro, you want me to make a free throw? Bro, can I just wet my own J?
As Charlie shoots a free throw, he exerts a relatively small amount of force on the ball, thus the ball travels a short distance into the basket. As Charlie desires to show off for the ladies, he displays the strength of his strapping biceps, exerting a much greater force in both the X and Y dimensions in order to launch the ball through the air, draining a half-court shot. Through Charlie's superior athleticism, we have efficiently explained and described the relationships within Newton's second law of motion: force equals mass times acceleration. As Charlie puts his invisible defender through the spin cycle, he dribbles the ball down the court. As the ball comes into contact with the ground, with force equal to its weight plus the force applied by Charlie's dribbling, the ground exerts a normal force equal and opposite to the aforementioned force, sending the ball back up into his hand. In this example, where we show what would happen if Newton's third law did not exist, I go up for the layup, and Charlie swats me into the abyss of the world. The ball rolls down and keeps going because there is no force opposing it. Normally, the wind resistance and friction of the ground would stop the ball, but in this case, it rolls all the way to Alaska.
Go.
I'm Andrew Berend, and I'm freezing. Welcome to Sports Science.
Things like that. All right, whatever.
Charlie's superior at
That is so funny.
What's up, guys? It's Charlie. Yeah.
What's up, bro?
Bro, punt, pass, kick, I am